In the second question, the equation of the vertical asymptote is, to find the vertical asymptote, you are going to equal the denominator by 0. You have to equal the denominator by 0 and move in -1 to the other side to make it x equals 1. And from the graph, you can see that vertical asymptote cuts the x at x equals 1. To make the answer is D, which is x equals 1. So the answer for 1 is A and for 2 is D. Examples on vertical asymptotes. To find the vertical asymptotes, if any of the graph of each rational function. A. R of x equals to 3 over x squared minus L1. Any vertical asymptotes needs from you to factorize the denominator and equal it by 0. It is difference between two squares. Difference between two squares. Factorize them and make it as x minus 1 and x plus 1. If you equal it by 0, you will get from each the vertical asymptotes, which are x equals minus 1 and x equals 1. In the second example, B, R of x equals to x plus 5 over x squared plus 1. You can see that this is not difference. This is sum of two squares. Sum of two squares, which is hard to be factorized. You can factorize it in real number sets. Because of that, no vertical asymptotes. There is no number, you can replace it instead of x and square it to be negative, then add it to 1 to get 0. Because of that, you can't equal the denominator by 0 in real set. So, no vertical asymptotes. In example 3c, R of x equals x minus 3 over x squared plus x minus 12, trinomial expression. If you equal it by 0, you can factorize it to get x minus 3 and x plus 4. And sometimes, if there is a way to cancel or a chance to cancel, please cancel it. Like x minus 3 and x minus 3 to get finally 1 over x plus 4. After that, if you equal x plus 4 by 0, after moving the plus 4 to the other side, you will make it x equals minus 4. And that will give you the vertical asymptote, where the denominator equal to 0, which is as x equals minus 4. The third type of asymptotes is the slant or the oblique asymptote, which is neither horizontal nor vertical. The equation of the slant asymptote can be written as the form y equals ax plus b. An example to understand it more. F of x equals to a rational function x squared over x minus 1 should be rational always, where the slant asymptote is y equals x plus 1, which is explained in the graph as that line. This is what we call it, the slant asymptote, which is neither horizontal nor vertical. Now you can draw it easily by using a small table including 3 points from your mind and replace instead of the point x by 3 points and add it to 1, then you can plot this line. For example, you can put instead of x 0. 0 plus 1 is 1. So you can get the first point is 0 and 1, like that, 0 and 1. Then you can plot the first point. Similar, you can plot other 2 points. Then you can connect between them easily to draw that line. That means you are drawing a line. But have a look, your curve never touches. Your curve never touch it. And in this graph, you can see that you have always a vertical asymptote at x equals to 1. This vertical asymptote, clear here in the graph, as x equals to 1. Also, your curve doesn't touch it. And when you're going to study the limit for this curve getting closer to the slant asymptote, you can see it is going to infinity from that branch and going to infinity from that branch and going to infinity from that branch and to infinity too from that branch. This graph has 4 branches. 1, 2, 3, 4 branches, all going to infinity. To find the equation of slant, which is the oblique asymptote of the function, you can use one of the following common ways. The first way is the long division, by dividing the polynomial of the numerator by the polynomial of the denominator. This is the polynomial of the numerator. You're going to divide it by the polynomial of the numerator. An example, if f of x equals x squared plus 2 over x minus 1, then the equation of the slant asymptote will be y equals x plus 1. Let us see how to divide. You're going to write the numerator here, x squared plus 2. It's better to leave a space between them because there is no x, and you have to reorder them descendingly or ascendingly, like that, x squared plus a space for x, because it is not written, plus 2, which has no x. This is all the expression of the numerator. Now, you can write here in this place the denominator, which is x minus 1. Now, let's start dividing. X squared divided by x. By subtracting powers, you will get x, write it up. Then, after dividing, you should multiply x by each. X by x is x squared, x squared, x squared. X again by minus 1 will give you minus x. Make it below that place because later on you will subtract. The third step is subtracting. Now you are going to change each sign from positive to negative and from negative to positive to subtract. So this was positive. Let's make it negative. This was negative. Make it positive. Now subtract. X squared minus x squared is 0. 0 plus x is plus x. 2 plus 0 is 2. Now we are going to do the same again. Dividing, multiplying, then subtracting. We're going to start again from here. X divided by x. That will give you plus 1. The first step is done. The second is multiply. plus 1 multiplied by x. That will give you plus x. Plus 1 multiplied by minus 1, which is minus 1. The third step is subtracting. So you need to change the signs from positive to negative, from negative to positive, and then subtract. Plus x minus x is 0, plus 2 plus 1 is a 3. Now you get the quotient of your division is x plus 2, which is your equation of the slant asymptote. Don't take the don't take the remainder. You are going to take the quotient only, which is x plus 1, and call it y equals. This is a linear equation. And when you're going to sketch it in the graph, you can choose 3 points from your mind, make them in a small table, and plot them in the graph. Then connect them with a broken line and make your curve doesn't touch it.